Let us continue on with reflected XSS. Now, what does reflected XSS means? Reflected XSS means the payload that you send to the server comes back unescaped in the response. Let us see this in action. This is the web page that we saw earlier. If I enter my name here, you can see there is a query parameter named name, and it is carrying the value Ram, that is my name. Now let us enter a payload here. This is the payload that I am sending. So when I click greet, the request, first it will go to the server. Let us see the server side code in action. So this server.js file is the one which handles our request. This part of the code handles our request. So what this does, it extracts the value out of the name parameter, and then it is calling another object or library called as EJS. So basically what this does, it is calling this index.ejs file. This is embedded JavaScript or template for Node. So our name parameter eventually lands here. So if you notice one thing, there is no function or method which is doing an escape on the input that we provided. Here it is directly extracting the value out of the name parameter, and then it is calling the template engine. Template engine itself, it has this functionality to do an escaping, but because of this minus, it won't escape. If it would have been equal to, it would have done an escape on that, but because it is a minus sign, a dash sign, it won't do escape on the input that we provided. So this section itself, when it calls, it creates the template or the response that the server is supposed to send back, and it will send back the response. Now let us see the same flow in a diagram. So we have a browser where we have the page loaded from localhost at port 3000. We're sending a payload to this application, and this app server this is an app server, and this is calling the template engine. Now escaping could have happened here, or it could have also happened here. This is the flow. Why am I drawing this diagram? I wanted to understand that we entered the input here. The input first landed here, and then it went to this template engine that I think it was index.ejs, yeah, right, and this was server.js. So our input started from here, it went to server.js, then it went to index.ejs, and then again the reverse flow. It came to server.js and it sent back the response. Throughout this flow, our input was this script alert 1. So this comes out unescaped. Now what does escaping means? Escaping means turning something harmful into a not harmful data, meaning you are sending something harmful in the payload, say a code or a malicious code, and when it comes back, the escaping function or library, what it will do, it will turn that harmful code into a non-harmful data. Now, what's so harmful about script alert1 script payload? Actually, nothing. It just displays or pops up with this one, that which we provided within alert. Right? We provided alert1 and it gave that as a pop-up. So nothing much harmful about it. But note that the payload that we entered, script alert1, came as is. It did not change. It did not got escaped. It came here unescaped. We'll come back to this later. Let us try a different payload on a different lab. This time around we will be trying to do something sensitive or something harmful with our payload, with our JavaScript code. I have this lab setup, the application setup. In this application you can only have two users, user A and user B. Let me log in as user A. So there is no password to this application. I'm just using my username. So in this application, with the note query parameter, we can inject the script. I'm using the vanilla payload, script alert 1. So we're getting a pop-up indication that XSS is possible. Let us do something harmful or try to access something sensitive. Rather than alert 1, let me alert and get the application's cookie. So here we get a pop-up with the string session is equal to user A. So we are getting the cookies data here. This is a session cookie. This cookie is containing the session data. This is user A's cookie. So cookie in web application world, cookie is akin to your ID or access card in real world. If you have access to someone else's ID card or access card, you can access the area or the place that that access card allows you to, right? Similarly, in web application world, if you have someone else's cookie, you'll be able to access their application data. To put it simply, to get someone's cookie is to take over their account. They call this attack account takeover. We logged in with user A and we accessed user A's cookie by doing document.cookie in script alert. Now what we will try to do, we will try to access user B's cookie. Being a user A, user A is the attacker now, user B is the victim, and we need to get user B's cookie so that we can do account takeover. Let us do that now. Let me just draw a diagram to see where we are at. So we logged in as user A and there is one app server at port 3000. Now user B is on a different system. We verified logging in as user A that we are able to access the cookie. Now let us first see inside user B's page what it looks like. I'm logging out as user A. Let me go inside user B's page. Similar to user A, let us write user B's personal secrets here. The secret is that user B is Shaktiman. Let us save this. So we have user B's secret identity. User B is actually Shaktiman. And user A let us have user A be Pikachu. So user A is Pikachu and Pikachu wants to know the identity of user B. Note that user B is also connected to the app server. User A is also connected to the app server. Now before Pikachu gets to know the user B's secret identity, using the XSS, Pikachu has to set up an exploit server. So Pikachu will set up a new machine, a new service running in a different port. So we have port 4000 acting as an exploit server. So far I've been using localhost, right? It need not be like this. We can also use www.evil.com as our exploit server. Idea is that if user B has access to internet, then it can not only reach the private or local services, it can also reach evil.com via internet. So let me set up an exploit server now. My exploit server is set up and ready. It is hosted at port 4000. So when user B becomes a victim of our XSS payload, the cookie from user B will be fetched and it will be logged here in this machine. So the idea is user B, when it becomes a victim to our XSS payload, their cookie will get stored here. So how does that happen? We'll craft a payload first, we'll examine the payload and you'll have a clear picture then. So this is the payload that I've come up with. This is the URL encoded form, this is non-URL encoded. So this particular link will be sent by user A to user B via an email or some other form, via chat box or something. So basically we are trying to do phishing. User A is trying to do phishing. So let us break down this payload. So this is visiting the application, right? The application that we saw earlier. But in the note query parameter, earlier we entered script alert, right? Document.cookie. This time around we are entering a different payload altogether. This is the image element. So this particular part, this section will be reflected in this particular area and the script will execute. So what does this part exactly does? It will try to load an image, but since source is an invalid value, the on error event attribute will kick in. So this part is actually trying to create a new image, and look at the image or the resource that it is trying to fetch from. It is trying to fetch it from localhost 4000. This is bogus because there is no image as such in the localhost 4000 port. This is the localhost 4000. This is an exploit server. It is made to steal cookies and cookies alone. It doesn't have any image. But even still, read this. We are trying to steal the cookie by appending this part. So this part particularly steals the cookie and appends it to the URL. So when we receive the request, the exploit server will receive the request. It will have the cookie attached to the request. Right, that's the idea. That's what this payload stands for. Let's move on to sending this payload to user B. And I've copied this payload. I have these two windows created. On the right side we have user B logged in, and on the left side we have user A logged in. So let's just imagine a scenario. User B is on their email, let's say Gmail, and they have got a mail from user A, a phishing mail, and they are asked to click on the link, this link. So user B clicks on it, and for them seemingly nothing wrong has happened, only a image error is shown here. But what has actually happened, just by them visiting the link, we got access to their cookie, session cookie. So this is the session cookie of user B. Now what is the significance of this? If I go to user A's page now, and if I go to inspect application and on the cookie, if I paste user B's session ID here and reload the page, I have access to user B's account. So essentially I have taken over user B's account. Now I know that he is Shaktiman. Taking a look back at the diagrammatical view, user A sent a phishing mail to user B, and user B clicked on that link that was in the mail, and user B visited localhost 4000. This is the exploit server. And when user B visited the exploit server, they also sent their cookie along with the request. Now user A can also visit the exploit server. They have actually visited the exploit server requesting the logs page. In this logs page, the user B's cookie were found, session cookie. And taking that session cookie, user A used it in their own browser, and they got access to user B's session. This was all made possible because of XSS being present in this application. I'll take a break for now. This video went way longer than I expected. I'll continue in the next one. Thank you so much for watching.